assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hi everybody. So we're trying to find the iodine isotope after it's ingested immediately and an hour later and 3 months later. And we were given the isotope as 131, iodine 3. Okay. Let me read that a little bit better. There we go. And we have immediately, and I'm just going to put that as IM. B is 1.5 hours. C, we have 3 months later. Now I'll put 3 months. And we're also given a mass of 782 new grams. And I'm just going to block this off so we know where it's at. Okay. And right now, we need to find an O for this so we can complete a problem. And we have the Avogadro's number, 6.023. If you take in chemistry, this is very similar to your chemistry. Mole. Okay. Then you have 131 grams per mole. And again, that's from this, okay? And here you have your weight that you were given in mules. So we have 782, but we want it in grams. So it would be 10 to the -6 grams. Now remember mu because some physics professors really like that number for some reason. And you get this for your NO 3.595 times 10 to the 18th nuclei. Okay. And just remember that. So for A, and here we're also, and before I continue with A, let me just write the equation that we're going to use. We have the decay constant, 0.693 divided by the half-life, okay? And here we have this, and it's going to be lambda T, and we have this, which is lambda and L, okay? So for A, we're just gonna solve for this. And we have 0.693. And we have a half-life for this. And here, oops, I forgot the E, guys. So here, we're using this equation right here. And the half-life, it looks like we have 8.0252 days. And again, you can either look in the appendix of your book or you can look it up on Google. And we have 1 day. We want these days to cancel. So we have 86400 seconds over 1 day. Okay. And then your NO is this. Okay. And now you're just going to plug everything into your calculator. And you're going to get 3.595 times 10 to the 12 K seconds. Okay. And this is your answer for part A. And part B, we have 1.5. We have 1.5. Okay. With that in mind, we now can go down to our R. So now we're using this equation to help us out. There we go. Okay. So we have 3.595 times 10 to the 12 decay second. Okay. And now we have E minus, and we're just going to make it a little bit bigger so we can see it. We don't need that. Okay. There we go. 9.3 divided by 8.025 times 86400 seconds. And we already know that it's going to cancel out, so I'm not going to add together just for the sake of the room that we have. And we also have 1.5 hours, and we're going to times that by 366 seconds, hour. Okay? And you're just going to plug all this huge thing into your calculator and do it in sections if you need to. And when we do that, we actually get 3.58 times 10 to 12 decay per second. So this is the answer for B. Okay, and now let's get down to C. So C, we have again your R. I'm going to put 3.59 times, you can put 5, there we go. 3.595 times 10 to the 12 decay per second. Okay? Times E to the negative. And we're going to repeat the same motion that we had earlier, which was 0.693 times 8 point, parentheses here, 0.252 times 8.6400 and we have 3 months later, which is 1/3. Oops, my bad, it's 1/4 of the year. 1/4 year. And that we have here 365 days per year. And then we also have to change the 365 days. So what I'm going to do is do year to seconds. So year to seconds. And if we do that, I'm actually just going to do this because this is going to be a little bit faster, okay? And if we do that, we have year here, And then the second is going to be 3 point. I guess we're just going to, there we go. Oh. I figure out what's going on, guys. Okay, there we go. We have year, and it looks like it's 3.15 times 10, and that's 1, 2, 3, 4, 5, 6, 7 seconds. Okay, and that way we can, we're crossing this out. And now we have everything in seconds. And with that out of the way, and we also have this crossing out, and that's fine because we have seconds down here. And with all that conversion, we should receive at 134 times 10 to the 9th K per second. Okay, and that's your answer for C. Okay, don't forget to convert your units and make sure you have your units out when you are converting, just in case you mess up. Sometimes it's this type of stuff that's going to mess up your entire problem. Okay, thank you guys.